In this video series, I'm going to explain how to set up a Raspberry Pi as a media center for a typical home television setup. In this video, I'm going to build the OpenELEC distribution that contains XBMC from scratch, and in the next video, I'll explain how to connect and configure an infrared remote control using a $1 infrared receiver that I connect directly to the GPIO pins. If you do this, then you can use your regular television remote control in order to control XBMC on the Raspberry Pi from the comfort of your armchair. From there, I will add more videos as I add more features to my home setup. There are some advantages in using XBMC on the Raspberry Pi for your media center. It's a flexible open hardware and open software solution that you can upgrade over time. It's a small, neat package that is very low cost. The entire cost of my solution is about €50, which is about $60, including the cabling. But yet, it's powerful. It can stream high definition 1080p video encoded in MPEG4 or MPEG2 to my television from local storage on its SD card or from network servers such as Windows Media Player and FOOPS or MediaToom running under Linux. Despite its low price and spec compared to a desktop PC, it has hardware accelerated video for H.264 standard, and you can buy a license for about €2.90 to make hardware accelerated MPEG2 available also. The feature that I like best is that it's an extremely low power solution, running at about 2.5 to 3.5 watts depending on what it's doing. XBMC is an open source media player and entertainment hub for your television. The user interface for XBMC is really nice. A lot of work has gone into developing a feature-rich system that allows users to install add-ons. For example, there's a great TED add-on that allows you to keep up with the latest TED Talks without having to leave your sofa. Why the OpenELEC distribution? Well, there's several distribution options such as RaspMC and XBMC. Well, it's probably down to personal preference. I find OpenELEC to be very polished, and while RaspMC is probably more flexible, I find the user interface for OpenELEC to be very smooth and playback to be very fast without any stuttering. From my experiences, OpenELEC seems to run with a lower CPU usage and does everything I need. It does need to be built if you want to use the latest distribution or make custom changes to the read-only file system. It's not too difficult to do that, and hopefully this video will help you. This is going to be a fairly long video, and to be honest, I'm not doing too much that you won't find in the guides on the OpenELEC wiki. However, if you're not used to building software under Linux, then hopefully you will find it useful to see me work through the steps and see mistakes that I make along the way. If you already have OpenELEC installed and you're interested in the infrared remote control part of this series only, then follow this link to the second video in the series where I explain how I have built that. Just in case you've never seen one before, this is the Raspberry Pi. This is the Model B, which means that it has a network adapter. It's one of the big changes. And this is a later revision of this board, which means that it has 512 megabytes of RAM. I think that came in October 2012. So this is the board. You can see here we have our network adapter. We have two USB ports. We have our indicator lights. There's an audio jack. This is a standard composite video output. We have our GPIO port pins here that we're going to use for the second part of this video when we connect the infrared receiver. Here's the power adapter. It's a micro USB adapter. That's something that if you haven't bought one of these boards before, you might be surprised to see it's actually micro USB rather than mini, which means it's probably the same sort of adapter that's on smartphones and so on. There's the main regulator on the board, our HDMI video output, which also carries the audio. So the HDMI will carry the audio stream, including Dolby Digital on the audio streams. One thing to be careful of with the board is that when you're plugging in and out the USB adapter to power it on and off, that you don't use the capacitor there for leverage, because one of the main problems with this board is the capacitor being unseated because of people forcing it out. On the board itself, you have your JTAG pins, you have an adapter if you wanted to connect a camera to it, an adapter for an LCD module, the main processor there, so that's a 700 megahertz. It's an ARM11 processor by Samsung. There's the Ethernet adapter. And that's really it. That's all we really need on the board. We're going to use the HDMI to connect to the television directly, the Ethernet adapter to connect to the network. USB, we can connect a keyboard to that just to get our configuration set up. You can also connect a very handy little Wi-Fi adapter, or Wi-Fi it's called. It's quite reasonable, quite low cost, and that allows us to get to enable wireless networking on our Raspberry Pi. We're also going to need a USB adapter to power the board as well through the USB micro input there. For this video, I'm going to use a brand new Ubuntu desktop installation. The reason for that is to ensure that everything is either part of standard Ubuntu distribution or it can be downloaded and installed within this video when I go to build OpenELEC. In this case here, I'm using a Windows machine, so I've installed VirtualBox. This is Oracle VirtualBox. It's a very powerful tool that allows you to install a guest operating system on your core operating system. In this case here, I've set up a VirtualBox installation with Ubuntu Desktop by downloading the distribution for Ubuntu Desktop. One thing just to be careful of when you're creating your Ubuntu installation, if you're doing this from scratch, is just remember to allocate plenty of disk space. The default values that VirtualBox chooses for memory and for disk space are very small, so make sure you're quite generous with those. You don't actually use up all that space until you actually need it within Linux, so it's better to over allocate. The other thing we need to do is to install guest under the guest editions, and the reason for that is because we want to have access to our SD card. So you need an SD card reader as part of your computer, and it means that you're going to have to actually install the guest editions in order to get access to your USB devices. So I'm installing guest editions, and this means that we can do certain other things as well. It's quite powerful in terms of using the graphics resources that are available to your main computer, but the big thing is actually the USB devices. It has support for shared folders, which is very handy because you can drag and drop files between your Linux machine and your desktop machine. It also has OpenGL drivers for 3D graphics support. So it's a very useful addition to your machine. Return to close the window. So that's our guest editions installed. The next thing we have to do is go off and download the source for OpenELEC. So at the moment I'm using a brand new desktop. I'm going to make a directory. I'm going to call it OpenELEC. And in this directory we want to download the source, so we're going to use git. So git clone git colon github.com/OpenELEC. Can't type today. /open git. Okay. And that goes off, connects to the repository using git, and downloads the full source code that you need for your OpenELEC build. So depending on your network connection, it can take quite a bit of time to download the files. There's a good bit of data to download. When that's done, we can then start the process of compiling. Okay, so that's done. So it's downloaded. That took about 5 minutes, not too long. So we can do ls. We can go into the directory, and we can see our project here. Now you should be able to just build it directly here on your machine, but this is a brand new installation, so there are tools we're going to have to install. So the guide that's linked at the bottom here, which is exactly what I'm going to go through, says that we should install certain packages that we need. This is the OpenELEC guide. So we can do that. We can say sudo apt get install and all of the package we need: G++, compiler, nasm, flex, bison, wk, gperf. It doesn't matter if you have some of these already, it'll just skip it. Okay, password. Okay, so yes to everything. So it goes off. Gets all of those packages. It was very quick. Okay, we also need auto point and X font utils. Very fast. Okay. And the other thing we need is for within Perl, it's sudo apt get install lib XML parser. Okay. So I think that's all of the packages that it recommends that we install in advance. So we'll see how we get on. Okay, so we can make a release version so that we can update in the future. So we can type project. You have to follow the exact same case. Project equals RPI, Raspberry Pi. Architecture, ARCH is ARM. And we go make release. RELEASE. Project equals RPI, capital R, capital P, small I. Architecture equals ARM, make release. And we're going to use a system. System lacks the following tools. Java. All right. Okay, I don't have Java installed. Okay, I have nothing. As I said, it was a very clean build. We'll use package map to aptitude is not installed. Yes, install aptitude as well. Okay, so it's another one that needs to be installed. To package upgraded, yeah, okay, just say yes to everything for my Java installation. This will be a big enough one. OpenJDK 6. Okay, so it's off, it's fully compiling, everything seems fine. Yeah, it's working away. So this could go on for quite some time. So I'll let you know exactly how long it takes. I'm going to take a break and just let it work away there. But it is going to be a number, at least an hour, maybe 2 hours, 2 full hours to compile. So it's compiling away, and depending on how fast your network connection is, your connection to the internet, and also how fast your machine or how much memory and CPU resources you allocated to your virtual box, in my situation, it'll affect how long it takes to compile. It should take about 1 to 2 hours to compile. At least that's how long it took before on a previous virtual machine. So it takes quite a while. So at this stage here, you can leave it go for a while. Hopefully you don't see it doesn't stop early at any stage. While that's compiling, one thing you might think about looking at is to go to the raspberrypi.com, to the Raspberry Pi store, and you could look into this. Now, the only problem is you can't buy it until after you've installed your operating system and you get your ID from your Raspberry Pi. But have a look at this, the license, and see what's involved and set up the account and so on. I would recommend that if you are going to use the Raspberry Pi for playing video, that you would install an MPEG2 license. And that's because there's a lot of material you probably have from before that is used an MPEG2 encoder, and to play it back you'll need this license because the software implementation of MPEG2 on the Raspberry Pi is very weak. This license allows you to use a hardware decoder and its performance is excellent. It's also useful if you're recording things like satellite television and you want to play it back later. If you've got a standard SD stream, it's probably encoded with MPEG2. the MPEG4 license for the hardware MPEG4 player is already on your Raspberry Pi. So the MPEG2 license, you can see it's €2.80. I think I paid about €2.90 for some reason, but €2.80 is what it says here, and or it was £2.40 sterling or something. And you can see that to buy this, you need to know the serial number, and I'll explain that later. So unfortunately, it says that it takes about 72 hours for you to get this license. It came for me within about 2 hours, so I'd say this is probably just to ensure that if there's nobody or if it's the weekend that you don't get it. The way that you get this ID that you need is you go into your Raspberry Pi, and at the command prompt you type cat /proc/CPU info, and that's where you get your serial number for your particular board. It's a unique serial number for your board. You put that serial number in there, you add to your cart, and you can buy your license key. Okay, so that's something I did, and I think it's worth doing. While OpenELEC is currently compiling, there's one other thing we have to do. We have to prepare the SD card to receive the image, the Linux image. So to do this, the first thing I'm going to do is I'm going to plug in my SD card into my reader on my computer. And you should see that you get your normal Windows message. In this case here, I'm running Windows with VirtualBox, so I get my Windows message and it says I have a drive, removable disk K, and here I've got a drive. I go properties. I have a new FAT32. It's got 32 gigabytes free, and that's really it. There's not much more to say about it. So that's it. It's got no title. So that's it in Windows. Now the thing is, we need that under our Linux virtual machine, and to do that here we have to activate the USB. Assuming you've got the guest editions installed, you go down here to USB devices and you choose the device here that relates to your card reader, your SD card reader. Now I know from trial and error that it's this one here, generic USB 2.0 C or W. That's my card reader on this machine. So when I activate this and give it over to the guest OS, you should see that within the Ubuntu desktop, it pops up. Okay, so there's my 32 gigabyte fast system, and it's mounted under media /6139-3233. Okay, so while that's going, it's still compiling in the background. I'll open another extern, and we should be able to see our card. So CD/media. There it is, 6139-3233. Okay, mount. We want to find out where it is, and we can see down here somewhere. It's coming up here. /dev/sdd1 on media 6139-3233. So SDD is my SD card. SDD. That's mounted SDD1. Okay, so that's useful to know. That means we know where what we're working with, and it means we're not going to accidentally prepare the wrong drive. So the next thing we want to do is we want to unmount it, because we're about to change it completely. We're going to change the file system. So ensure that there's nothing on this SD card that you need. It should be completely blank at this stage. So, and what I'm about to do here will destroy any data on it. So sudo unmount dev/sdd. Enter my password, and it's unmounted. Oh, SDD. Okay. So now we can see mount, and you can see there's no SDD1 now mounted on my machine. So the next thing we're going to do is we're going to partition it, and we need to create an MS-DOS partition first. So to do that, we'll do sudo parted -s /dev/sdd, and we'll make label MS-DOS. Okay, so that worked. We now also have to create the partition, the FAT32 partition. This has to be 128 megabytes. So SDD should be replaced with whatever your SD card appears at. It could be SDB, it depends on the number of drives in your machine. Unit cylinder. Primary. 32, just make this a little bit wider. Still going on in the background. Minus minus space 0 space 116. Okay, so that worked. We want to have this as bootable. SDD set one boot on. Okay, so we're ready to go. That's that. Next, we have to create the second partition. We're going to use all of the space. This is going to be our media storage device. X2 file system. 16 minus 2. This, you can get this from the guide on setting up OpenELEC. It's nothing, you'll get everything there, but just to see it working. So let's get our information. So here we go. So you can see here that we should, after all those instructions, before we format the partitions, we have our first drive. This is 31.9 gigabytes, and you can see that the primary partition, we have our 128 megabytes and whatever remains. The second one is ext2, and the first one we have our Linux swap and everything set up there. So we want to set the system labels and format next. So sudo mkfs.vfat -n system /dev/sdd1. Okay, sudo fs.ext4 -l storage /dev/sdd2. Okay, seems to be working. Okay, writing super blocks and file system counting information. Everything's still working away in the background. No major problems yet. Okay, and the final thing we want to part probe. This ensures the kernel sees our new partition layout. Okay, I still have that message SR0, don't mind that, that's to do with my system. Okay, so if everything's working now, we should have our SD card should have two partitions. So I'm just going to check this, and the way I'm going to do this is to pull out the SD card and put it back in again. Okay, so now I should have had, yeah, two windows pop up. I have my system, which is my FAT32 partition, and my storage. So that's what I would expect to happen, and you can see they're both appearing on my, if I can just grab this, yeah, here we go. Xbox, my storage and system. So it looks as now as if I've plugged two drives in. One is my FAT and one is my EXT partition. Okay, just check my mount. And you can see that they're mounted here. There's my SDD2, which is my storage. It's the big part of the SD card, which is ext4, and the small part is VFAT, and that's SDD1. Okay, so we still have to wait now. Unfortunately, we have to wait till we're ready to go. Both drives are mounted and we're ready to do the next step, but we have to wait till the compilation is finished. Okay, OpenELEC has finished compiling, and you can see I haven't got any serious error messages here, so this means that it's complete. One thing that I noticed halfway through, and I think it's useful to point out, is make sure when you set up your machine in VirtualBox that you allocate multiple processors for your compilation. I had it set to one CPU and it was going to take a long time. So in this case here I over allocated, but you should allocate it to a greater number, and it sped up the compilation significantly. So it still takes with 8 processors, it probably still took about an hour and a half to compile. So don't be surprised if it goes on. Okay, so here's my system, and let's just check our mount again. We have our SDD 1 and 2, where 2 is our storage and 1 is our system, and they're mounted under media storage and media system, so we could access them in that way. So the next thing we've got to do is copy the compiled OpenELEC installation onto our card, and we also have to copy off across the bootloader. Here's my directory, and my build has happened, and my target has been built, so everything is in order. The next thing I have to do is I have to copy the files onto my SD card that we prepared earlier. So you remember my SD card is mounted as SDD1 and SDD2, and system and storage. Currently these two folders are empty. To mount them, you can, if everything's working correctly, you can just simply insert the SD card and they'll appear as mounted, or you can do sudo mount /dev/sdd1 /media/system and sdb2 /media /storage for the other one. So we'll just have a look /media, and CD storage is going to be empty, just the lost and found directory, and system is currently empty, so I'll keep that there. My system directory is empty, so we need to copy over the files we need for our to boot our OpenELEC on our Raspberry Pi. So the first thing we do is we go into build, the build directory, OpenELEC RPI ARM development, and in here we've all of our build files. So we're going to go into the directory. We're going to go into the directory BCM, and there's two of them. There's bootloader and driver, so we want to go into the bootloader directory, and in here we have the files that we need. So the first one we need is start.elf, so we're going to copy start.elf over to /media/system. I don't think I need to sudo. No, I don't need. If you do it, we'll do it sudo just in case. I don't think you do though. Okay, so that's copied our start.elf over. What else do we have to copy over? Our bootcode.bin, and the same /media/system. So those two files are over there, so just check that. So at the moment I've got bootcode.bin and start.elf. There's a mention of loader.bin on the website, but that's not needed anymore. It's not present, it's not needed anymore. Start.elf will call the bootcode directly, so that's fine. So that's those two files. We go back out. I'm back in my build directory, and we want to go into target. And here we've got our kernel and system. So we want to copy these onto the same directory and the same drive. So we copy the kernel. .kernel. Just press tab and it fills it in. and we want to call this to /media/system, and we just have to change its name. We want to call it kernel, kernel.img. Okay, and we have to do the same thing. Copy OpenELEC dot, just be very careful here. That's system. I'm going to copy system, media, system, and we want to call this system in all capitals, SYSTEM in all capitals. Okay, this one's a big file. System is very large. Let's see where we're at the moment. So it looks like 88 megabytes. So it's still copying over. Wait till that copies over fully. And we're in order, I think. Oh, there's just one other thing. We just want to give the parameters. Let's check that that's right. Yeah, 88 megabytes. That's right. Okay. So we have to make one more file here. And the way it suggests we do that is we can do that here. Just make this bigger. Echo. We're in the system directory, media system. Boot equals /dev/mmcblk0 p1, and that tells OpenELEC the partition which contains the kernel image and the system file. So this is that partition, and the disk, whoops, equals /dev/mmcblk0p2, and that's the storage partition. We want to enable secure shell so that we can secure shell in from here into our Raspberry Pi when it's connected to the television, and quiet mode. So we want to echo that, pipe sudo t, and we want to put this into a file called command line. Command line.txt in the current directory, which is on the SD card in the system directory. Okay, so it should be in that. So if we more command line, yeah, it's there. Boot equals, this one's important, you get this right. Boot equals /dev/mmcblk0p1 space disk equals /dev/mmcblk0p2 space ssh space quiet, QUIET. Yeah, okay, so that looks good. So I think everything's in order there. We'll just go leave this directory because I want to unmount it. And what are the mount points again? umount /dev/sdd2 and umount /dev/sdd1. You might have to sudo that depending on your system. Okay. Yeah, they're both unmounted, so it's safe to take the SD card out. And I'm going to put it into my Raspberry Pi and start it for the first time. I just have a small case here, just a plastic case. So the Raspberry Pi sits neatly into that. Like it in at the edges. And it's a nice neat case. Okay, so it's in on all four sides. There's loads of these type of cases available. And it keeps the box, it keeps everything neat and tidy, and we've full access then to plug in our SD card directly into it. It still sticks out quite a bit out of the case, the SD card. Looks a little bit flimsy, but it's okay. But that would fit quite neatly behind the television. So for a wireless setup, this is what the final setup looks like. You have your Raspberry Pi, preferably in a box to keep the dust off it. The HDMI cable that runs directly to your television. Your micro USB for power. You can get an adapter like this that powers. This is a UK adapter, Ireland, UK, USB charger. And you can use an adapter like this to provide power to your Raspberry Pi. Usually they're multifunction, so it's just a standard female USB adapter on the bottom. And your SD card sticks out there, and if you're using a wireless network, something like the Wi-Fi would be very useful. If you're using fixed line network, the alternative is to use standard Cat5 connector and plug this into the back, and if you have Cat5 near your television, that's probably a more stable and better solution. So that's the final box that will be placed in behind your television, and as I said in the second part, you need a small box, something like this, in order to contain the receiver. So you could have a little box with the receiver circuit that just barely sticks out underneath the television and allows you to have the infrared receiver set up and any other LED indicator lights that you need. So a €1 box like this would do the job, and we could put our circuit board for our wireless receiver in there, our infrared receiver in there for the second part of the video. So here's my Raspberry Pi booting for the first time. It takes slightly longer for OpenELEC to start up the first time because it has to create the secure shell keys, the swap file and the folder structure that XBMC needs. Okay, so it's come up and you can see this is the XBMC, this is the standard user interface, and I have my remote control set up so I can move left, right, up, down, and I can go to see, for example, the weather forecast. .9 Fahrenheit? I hope not. Feels like 7 Fahrenheit. Oh, there we go. 43 Fahrenheit. That's a bit better. You can see the 10-day forecast is appearing. For some reason it's decided that I'm in Burr. We can change that and change exactly how that appears. I can use the left-right arrow to get the 10-day forecast, even the map and alert. So it's very useful to have that on the television. If I back up to the main menu, I can see pictures, music, programs, system. So press system for a second and we can see our appearance, so you can change that to other appearance, other skins, so you can install other skins and download other skins. I don't think there's any need to do that here. We can get system settings, so you can change whatever your output values you need. Under system, we can get the system info, and here we can see we've 82 megabytes of free memory. The IP address is here, which is very useful, 192.168.1.107, so we can work with that. We can see the CPU usage and storage information, network information and so on. So the storage information, well, I've only used 1% of my space, so I have 29 gigabytes free on my SD card for media. There's my serial number for my hardware information, so you can use that there. That's interesting. You can use that there to get your license for your MPEG2 that you can put on your config.txt. Go back to the main menu. So under videos, I go files, and I can browse. I can add whatever I want. So I've already added this, but if you wanted to add in a share, we can browse. How does that have to happen? Browse. So UPnP devices. This allows you to find your media servers. So that's the main one for the house. I've set up one which is MediaToom, which is installed on Linux. But you can see that's the main. That's the one for this. We'll do for the demo. We can press OK to store that, and that will then add that to my. And I'm just using my remote control for all this. So it's just a copy of the same one. So we can go in here into video, and we can see that I have my folders. Try again. TV recordings, I think it's called, for demo. Hobbit trailer. My audio's working, everything's working perfectly. I don't know if you can see the quality again, but it's really excellent. It's perfect quality, lovely smooth movement, no issues. Can I see the main menu? Right, I'm back at my computer, and we know from looking at the system settings within the Raspberry Pi and OpenELEC on the television with XBMC, we can see the IP address that's been allocated to the device was 192.168.1.107, so we can secure shell to that. The can't be established. Do you want to continue? Yes, we do. We're going to add it to our list. Permanently add it to the list to that. Okay. So the very first time we log in, it's going to try and log in as Malloy-D. So we need to cancel that. So we'll try again, and we need to log in as root. And the root password for OpenELEC is OpenELEC, OPENELEC. One of the problems with this is you can't actually do password here, and that's because OpenELEC has a read-only file system. So the only way to change the password, if you're really concerned about this, is to actually do it at the compile time. Now, it's a bit late telling you that, but you would have to actually change some files at that time. So you'll have to look that up to see how to do that. But this is just a media player on your television in your home network behind a firewall. So it's probably safe enough that's the configuration. So here we are. We're in a system. And just to show you the issue with the MPEG decoder, we can check to see if we have an MPEG2 hardware decoder license installed. We can do that by typing VCGEN CMD codec enabled MPG2, and you can see here that we get back VCGEN CMD codec enabled MPEG2 MPEG equals disabled. So it means that we don't have hardware MPEG decoding on this machine as yet. And you can go to raspberrypi.com, get your license there according to the address that you get. And the way that you find your address is you have to type the way you get your address to use on the raspberrypi.com site is you have to type cat/proc/CPU info, and this gives you your serial number for your particular device. So you enter that serial number and you pay your €2.90, I think it was, and you'll get your license code. And once you have your license code, well, you have to take the SD card back out again and place it into your SD card reader. So I'm going to do that now, and the way I'm going to do that is by typing. So I'm going to do that now, and the way I'm going to do that is by going back to the television and shutting it down through XBMC directly. So as soon as I shut it down, the XBMC directly on the television, you'll see that it closed off my secure shell connection to my machine. I've just plugged the SD card back into my computer. And I'm going to go to, okay, I'm on my machine here. So CD/media. And my two folders are there. So go into System. And I have to create another file. And this is the one that's going to contain my code for my MPEG2 decoder. So I'm going to edit this. vi-config.txt. I'm going to add one line of code. Decode underscore MPG2 equals 0 by 1, 2, 3, 4, 5, 6, 7, 8. Now, obviously, that's not the real code, but it's probably not wise for me to broadcast the real code on the internet. So I'm going to just save it as this: escape : WQ, and then you can see in this directory we have our config.txt, and that contains my not real code. So I'm just going to edit this now, pause the video, edit this code, and place in the correct code. So I've placed in the correct code, and now I'm going to unmount again. Oh, I'm sitting on this drive. That's a common mistake. I'm sitting on media system, so I can't unmount it. CD to go home. Okay, so I've unmounted, so I can take my SD card out again, and I'm going to boot my machine again. I'm just going to do one more time, just to show you the last step. So I'm just going to log in one last time. Okay, password OpenELEC. 74, and we just want to call the same command again: vcgen cmd codec MPEG2 equals enabled. So you can see here it's very clear that that's now working for MPEG2 as well. There's one other suggestion in the installation guide, which is to enable dirty region redraw on XBMC. It's supposed to improve the performance. So I'm going to do that as well, just to finish off. So inside here, inside storage, we have a hidden directory for XBMC and for our config. So we'll use the config one when we go to build a remote control. So we want to build a remote control. This is where we're going to do our system setup. Again, this is a read-only file system, so any changes that we want to make, or any, like for example, if we want to do something with the device drivers in ModProbe, we make the changes here locally. We don't make the changes where we would normally do if we had root access to an operating system. So in the case of XBMC, we make the changes in the XBMC directory. So here's our directory, and we can go into user data, and you can see here some of the configuration settings. So the configuration settings for the GUI settings are all here, and there's nothing to stop us from editing them here. And if there's some setting that you need to get access to, you make the change here, reboot the device, and it'll be applied. The dirty region redraw on XBMC, the way you do this is you have to create a new file, and the way we're going to do that called advanced settings. So vi advanced settings .xml. So vi advanced settings.xml, and we're going to add in a few values. XML, this is in the guide, version equals 1.0, encoding equals UTF 8 question mark there. Advanced, the open tag, GUI, algorithm 30. Okay. Algorithm 30 regions 1/algorithm 30 regions. No flip timeout 1000 / no flip timeout /GUI /advanced. So question mark XML version equals 1.0 encoding equals UTF-8 question mark. Okay, advanced settings /advanced settings GUI /GUI. I think I have that right. Escape :WQ more advanced settings.xml. So there's my file there. So if I've entered that correctly, when I reboot, this will be enabled. The problem is, this is what I'm getting. It's clearly working, but I have no nice user interface. Oh no, that's terrible. I'm going to undo that change. I've secure shelled back into my Raspberry Pi to fix the problem. So remember, it was in the config, the XBMC directory. Oops. User data, and there was advanced settings. So I'm just going to VI advanced settings XML, and I'm just going to delete out this section. I'm not going to get rid of it yet. DD on a line just deletes the line. Escape :WQ. I'm not going to delete the file yet, because for tuning the remote control, for the infrared remote control, there are settings in there that are, or that may be useful to help you avoid repeated key presses. Okay, that's it. My build is working correctly and the video is playing smoothly on the television. In the next video that's linked here, I'm going to add on infrared remote control functionality using a low-cost infrared receiver that I will connect directly to the GPIO pins. Good luck with your build.